Alright guys, today we're going to be doing some stations. So our learning target today is I can perform a sequence of transformations. I can show congruence by giving the sequence of rigid transformations that maps a figure onto another. So we're going to be reviewing through 1.14 and 1.15 today. So we're going to be focusing on sequences, so just doing multiple transformations at once. And then we'll also be working on showing congruence. So we want to make sure that these figures are congruent as we're going through this. So those are the two things that we'll be focusing on. This is a lot of what your test will be focusing on as well, being able to complete these sequences. So let's go ahead and get started. Now, for this first one, this is just an example, so we'll walk through it together, and then the rest of them, you'll work on them, and then we'll walk through them as well. So, which rigid motion will correctly map ABCD to JKLM? So I'm trying to get ABCD over to JKLM. So I'm trying to move it over. So the first thing I'm going to do is I'm going to go ahead and reflect over the y-axis. Because as we can see, these have different orientations. One's facing one way, the other in the opposite way. So if I reflect it, now all of a sudden they have the same orientation. Also, we can see that A will now map onto J, B will map onto K, C will map onto L, and D will map onto M. So we need to make sure that we're keeping an eye out for this. A must go onto J. If they're both first, they both must go together. If they're both written second, they must also go together, and so on and so forth. But that is very important that we keep track of that. So now we can see A will go to J, B prime will go to K, C prime will go to L, and D prime will go to M. But how can I move those there? Well, now we're going to do a translation. And our translation will be along the vector -2, -13. Which brings me all the way down. So again, if we're looking at our grid, we can see that it's going up by 2 each and every time. So we need to be aware of that as we're naming these vectors, because it's to the left 2, that's one block, and then down 1, 3, 5, 7, 9, 11, 13. So a total of 13 down. All right, let's go ahead and start some. Again, try these ones out on your own. Pause the video if you need to, and then we'll go through them together. So let's go ahead and start our stations review. So for all of these, we're going to use the definition of congruence to decide whether the two figures are congruent. And then B, we're going to complete the explanation and give coordinate notation for the transformations you use. So to complete our explanation, we actually need to show what we're using, what transformations we're using. And then for congruence, we need to use our definition of congruence. So looking at these two figures, FGE, or EFG if you'd prefer, and JKL, you want to map EFG onto JKL. All right, go ahead and pause the video, try this one out if you'd like, and then we'll continue through it together. All right, so looking at this, first off, these two figures look like they're congruent. They appear to be the same figure. It looks like they have the same type of slope going on and the same distance across each point. So it looks like there would be some rigid motions that would map one figure onto the other. So we're going to go ahead and move EFG over to JKL. To do that, the first thing I did is I did a reflection over the x-axis, which brought my original pre-image down to quadrant 3. From here, they now have the same orientation, so I can just go ahead and translate my figure over along the vector 8, 0. That will map E prime, F prime, G prime to triangle JKL, thus proving congruency. Also, just a quick note, please do not forget that this is called component form. If you haven't forgotten that vocabulary, awesome, but if you have, this is component form. And then, along with that, I have xy turns to x plus 8, comma, negative y for our final answer. Now, you guys may have a different route to get here, but if you combine everything together, it should be that same final answer as me. So everyone should end up with xy turns to x plus 8 negative y. This part may be different in part B when you're doing the initial work, but this final answer, if we put it all together, even if I do something else like go in a vector up to quadrant 1 and then move down to quadrant 4, this answer should still be the same when I combine everything. All right, let's go ahead and continue on. Go ahead and pause the video, try this one out, same type of thing. All right, so for this one, I'm trying to get E, F, G, D onto W, X, Y, Z. So I need to map these figures on top of each other. To do that, we're going to go ahead and start with a reflection. So I take E, F, G, D, and I reflect it over the line y equals 0, which is also our x-axis, our line of reflection. What that does is it gives us our green figure here. So we now have D prime, G prime, F prime, E prime. And now they're facing the same way. They have the same orientation. So from here I can go ahead and translate it along the vector negative 10, 0, which will move F prime right on top of Y. And that will show congruency because these figures will map perfectly on top of each other, so therefore they should be congruent. And again, if I combine my two transformations together, it should turn to xy, turns to x minus 10, comma, negative y. All right, let's continue on. Next, number 3. Use the definition of congruence to decide whether the two figures are congruent. Then complete the explanation, give coordinate notation for the transformations you use. Go ahead and pause the video, try this one out, then we'll continue on together. All right, so looking at it, it appears that these two figures are congruent. A, B, C, D, E is congruent to P, Q, R, S, T. It just looks that way based upon its shape, the slopes, the angle measures, everything seems the same. So we went ahead and did a translation. So I went ahead and I moved this bottom figure, P, Q, R, S, T, and I translated it along the vector 3, 8. So I went to the right 3, half a block and then one full block. And I went up 8, 4 full blocks, which mapped Q right on top of B, P onto A, T onto E, and the same for the rest of the points, giving us this green figure here. And since these landed perfectly on top of each other, these are congruent figures. So therefore, it's just a translation along the vector 3, 8. And again, this is notation form up top, component form down below. All right, let's continue on. Number 4, go ahead and pause the video if you'd like. We can try this one out in just a second. All right, so looking at these two, these figures appear to be different. So what I did is I went ahead and I found the length of all sides. Now, segment LM is congruent to segment XY, so these two are congruent, but those are the only two congruent pieces of these triangles. This side length is radical 68 over here, XZ, which corresponds to MN, which is radical 73 in length. Meanwhile, ZY is 2 rad 13 in length, and LN is 3 rad 15 in length. I found these using Pythagorean's theorem. So for instance, for ZY, I did 4 squared plus 6 squared, which gave me 16 plus 36, which gives me 52 equals ZY squared. So then you take the square root of both sides, you get ZY equals radical 52, which we can then simplify into 4 rad 13. So this is 4 times 13. I can take the 4 out. So that's how you can go ahead and find these lengths. That's what I did with each length to find the total. And then from there, as soon as I see that the corresponding side lengths are not the same, I can automatically stop and say, hey, these two triangles are not congruent because they are not the same figure. And again, there is no rigid motion that I can do that will map one figure onto the other such that they are, there's only overlap, there's nothing hanging off the side or anything like that. All right. Continuing on, go ahead and try this one out on your own. Pause the video, and then we'll come back together and complete it. All right, so looking at this, we're doing the same exact thing. We're trying to prove that they're congruent. Looking at these two figures, it seems like they are congruent. That's 2.5. That's 2.5 in length. This is 8 in length. 4 boxes total. This is 4 boxes total as well, so they appear to be congruent. So I need to map STUV onto WXYZ. So let's pay attention to this here, because this can get mixed up really easily. S needs to go on top of W. So I look here, S is over here, W is over here. They do not have the same orientation, because again, S is on the far left, W is on the far right. So I cannot just do a translation, because that would map S right on top of Z. But S needs to go on top of W. So we're going to go ahead and do a reflection. I did a reflection over the y-axis here, over the line x equals 0. And that gives me my green figure. My green figure here. U prime, T prime, S prime, V prime. From here, now S will be mapped with W. So S will go right on top of W now. So they are now orientated the same direction. So I can just translate along the vector -2, -3, which will map S prime right on top of W. So now that S prime is on top of W, T prime is on top of X. Let's make sure that's true. That is true. U prime will be on top of Y, and V prime will be on top of Z. So all of our points are now on their corresponding points. These figures mapped up, so they are congruent. All right, number 6. Go ahead and pause the video, try this one out. We're trying to prove that triangle ABC is congruent to triangle DEF. All right, so looking at this one, we need to get point A on top of point D. So that's our main goal to get started. So what I did is I first did a 180-degree rotation about the origin, because again, A needs to map on top of D. If I just do a reflection, A would then be able to move on top of E. But if I do a rotation, now A is facing the same direction as D. So with triangle A prime, B prime, C prime, we did a full 180-degree rotation about the origin. And as we can see here, we can draw these segments from the origin to our endpoint of the triangle, same on the other one, to our image. And we can measure this angle, and this angle would be 180 degrees. So that's how you're going to measure the angle. You could use a protractor right here just to measure that if you need to. At this point, we're going to go ahead and move A prime, B prime, C prime along the vector 1, 6. So I move right 1, which is half a block, up 6, which is 3 full blocks, and now I'll map A prime right on top of D. C prime will fall on top of F, and B prime will fall on top of E. Again, I listed the amount that we're rotating. I do not need the direction of rotation for 180 degrees, and then the point that we're rotating about. Also, I wrote the vector in component form, as well as coordinate notation. And then again, if we put everything together, we get xy turns to -x plus 1, -y plus 6. No matter what series you did here, as long as you mapped them on top of each other, this end result should be the same no matter what. This can be completely different though. If you get a different answer while you're going through this, different process, that's fine. But at the end, when you combine everything, if you did it all correctly, you should get the same final answer. All right, let's go ahead and continue. We only got a couple more. Next up, number 7. Oh, here's an alternate solution. So if I wanted to do it in one single transformation, I could have rotated 180 degrees about this point here, which is the point 1, 2.5. 1, 3. Half, 3. So if I rotate around the point 1/2, 3, 180 degrees, point B will map onto point E, which is what we want. A will rotate all the way over to D, and C will rotate over to F. So again, this is a faster method. It takes out the translation completely. I would like you guys to look for these types of things. You don't need to. It will create a faster solution, and it will be more efficient down the road, but you do not need to do this. I just encourage you guys to do it for time's sake, And just if you want a little bit of an extra challenge here and there, if you finish early and you want to condense it down, you can definitely do that. But this is just one alternate solution. All right, number 7, go ahead and pause the video, and then we'll continue on after. All right, so looking at this, we have DEFGH is congruent to PQRST. So, looking at these two figures, they appear to be congruent. It looks like there's a sequence of rigid transformations that will map one on top of the other. So, I'm going to go ahead and start with a reflection over the y-axis. So, I'm moving PQRST over to DEFGH. So I reflect across the y-axis. And again, if I'm going the opposite way, then I would have just translated down first and then reflected. But regardless, it should be the same. So I reflect over the y-axis, giving me P prime, Q prime, R prime, S prime, T prime. And then I go ahead and I translate just straight up along the vector 0, 7. So I don't move left or right, I just move upward. All right. And that's it for this one. Again, we have component form here, and if we write it all out into one single transformation, it is xy turns to negative x, comma, y plus 7. All right, number 8, go ahead and pause the video if you'd like, try this one out, and then we'll do it together. Okay, looking at this one. So, to get started, we want to map C onto W. So looking at this, C needs to go to W. So I can't just do a reflection here, a translation or anything. We must do a rotation in order to map C onto W. So I did a 180-degree rotation about the origin, which will bring point C, which is in quadrant 4, over to C prime, which is in quadrant 2. So that is my main goal to get started. I don't know why it says 5 here. There should be a 2. Should definitely be a 2. So C will now map onto C prime, and then from there I can just do a translation along the vector negative 2, 0, which will bring C prime right on top of W. So again, all of our work is right here. This can all be different. You can go about it a different process to get here, but our end goal should be the same. At the end of it, it should look relatively similar. So xy turns to negative x minus 2, comma, negative y. All right, and our final problem for the day, number 9. Again, same type of thing. So it appears that these two figures are similar. It looks like there is a rigid motion that will map one figure on top of the other. So let's go ahead and do that. So I'm mapping the top figure to the bottom figure. So the first thing I did is I took LMIJK and I went ahead and I reflected it across the x-axis. That gave me this blue figure down here, but they're not perfectly on top of each other yet. So I go ahead and I translate it along the vector 2, 0 in component form, and that will map L prime, M prime, I prime, J prime, K prime to A, B, C, D, E. So these two figures are now mapped together. It looks like they're congruent because they map perfectly on top of each other. So again, here's all of this extra work. XY turns to X negative Y, which turns to x plus 2, comma, y. And our final answer for this should be xy turns to x plus 2, comma, negative y. So that is it for our transformations. Please make sure that you guys are memorizing your rules. You guys do have a test on this on Friday. These rules will be a lifesaver for you guys, so make sure that you're working on memorizing them. Other than that, thank you guys for watching. Have a great rest of your day. If you have any questions, please let me know. Thank you.